How we doing, guys? This is hopefully one of several videos I'm going to talk with you guys about on tapered roller bearing setup. We're entering into an area where we're going to start talking about manual transmissions, transfer cases, and axles. And one thing that they all have in common is in a lot of cases they'll utilize a tapered roller bearing for shaft setup or pinion shaft or carrier or input-output shaft setup or control within the assembly. So your conventional tapered roller bearing looks like this. This particular assembly would actually be typically referred to as the bearing itself. This is sometimes referred to as a cone. This part right here is considered the cup or the race. So when somebody says I need a bearing race, this is probably what they're referring to. If they need the bearing itself, this is what the bearing is. The reality, though, is this is an assembly. If something was to fail, the roller was to fail, or you got into a situation where this needed to be serviced, you would buy a set. You'd actually buy this in a package with this. I know in some applications this could be potentially ordered separate, but if you do replace this, this also needs to be replaced. Also, what you're going to find as we move forward in talking about these bearing setups, if there's two of these assemblies on a shaft, let's say it's an axle shaft, or let's say it's a transmission assembly, this is the input and then you've got the output bearing, or if you've got a differential and this is a pinion bearing, you have a pinion bearing large end and a pinion bearing small end, they would both sets need to be replaced if they were set up. So just be in mind that if there's anything on the assembly that this actually runs against, if there's another, if this is a full shaft and there's another set of bearings on either end, both of these bearings would need to be replaced if one of them was to fail. The reason for that, and a lot of people don't realize that, is the rollers themselves, these rollers that's been around in here, over time, they will actually have a surface or a micro finish that wears off of that. And then as that wears out, you could actually have a bearing that looks fine, but you've actually worn a significant amount of that micro finish off. And then if you were to set this assembly up under factory settings, as a procedure I'm going to take you through, you may actually burn in a very short period of time through that factory, through that micro finish into that softer part of the roller. That softer part of the roller is obviously not as hard, and what happens is it brindles. It actually flakes off. You'll actually see almost looks like a chrome. You can put your fingernail underneath that. It's called a brindling bearing. You failed the bearing. So basically, if you have one of these out of an assembly and you're making an adjustment, or you've moved the shaft, or you've changed things around, this will need to be replaced. Costs associated with the bearings themselves, obviously a big guy like this is going to be pretty expensive. But the smaller bearings you see in a differential, or the smaller bearings like you see in an axle bearing or something like that, aren't that expensive, and your labor is very expensive. So in most cases, we opt on the side of replacing all bearings. Where this is typically done is in a ring and pinion set. If you set up a differential and you change the ring and pinion assembly, you would replace all bearings in that process. I do not recommend reusing the old bearings. Some guys will if they're just kind of throwing a different ratio at a car and they just want to test it. But if you're looking for longevity, you want to get 100,000 miles out of your differential, you're going to want to replace these bearings. So that's a traditional roller style bearing. And another thing that a lot of people don't realize on these bearings is the bearing themselves, the roller itself is actually barrel shaped. So if you were to take the roller out, you'd actually notice, and if you were to measure it, and again, I'm exaggerating this in my drawing, but the roller itself is actually barrel shaped, meaning the center of the roller, if you were to measure from here to here, this distance is greater than what is on the outside edge. Okay, and what that does is it gives it more lifetime usage. So when you set your bearing up, your race assembly is going to be perfectly flat, but you'll notice that the roller itself will only come in contact patch with that race at the center portion. To kind of illustrate that, I will take the race itself, and I'm going to mark this up with a little marker. I'm just going to draw a little bit of a line across the race, and then I'm going to put the bearing into the race. Now I'm just going to apply a little bit of pressure and roll it back and forth if I can. Oops, put this on the table. Roll this guy back and forth, okay? And then you'll see the transfer patch across the roller. You can hardly see it in there, but you can actually see that the transfer patch is in the center. So it's only cleaned off just the center port of that. So in that particular case, what you're going to find when you set up a set of bearings is when you put the race in there, the rollers are actually only coming into contact with the race along the center portion of that race. Over time, as the bearing wears out, and this will actually occur in a very, very short period of time, is the roller itself pattern will actually widen across the race, and then you'll eventually get a full support of that roller. That's during what they call the break-in procedure. But prior to that, you're actually setting the bearing up probably tighter than you think, you know, when you initially set it up, anticipating that amount of wear that will occur across that bearing. Now, that wear that occurs in the initial break-in is what makes these a match set. So over time, if you were to get one of these out and you were to take this out, if you were to confuse what side of the car this went on, or you got into a situation where maybe this was damaged and you wanted to replace this without this, you can't do it. They don't recommend doing that, because once this assembly is run together for any period of time, they become a match set, and at that point you're going to leave those two assemblies together. In the process of doing this, selecting the amount of pressure that you want to put across that roller is called preload. Now, this is the difficult part of this assembly. Setting up a differential preload, or pinion preload, or a roller bearing preload is done through a series of steps. And I'm going to do this in a later video, but I just want to kind of get the basics here. What preload is the amount of crush in the thousandths of an inch of how much pressure I'm putting across the bearing. So big bearing like this may actually be set up to about 6 thousandths preload. What that means is I'm actually going to crush this bearing from zero end play, from no looseness whatsoever. I'm going to put a pressure on this equivalent to the movement of 6 thousandths of an inch. It doesn't really sound like a lot, but I tell you what, it'll actually create quite the resistance or rotation on this assembly, especially the larger ones. So when you start setting these things up, and they talk in the service manual, they want you to set it up to a certain amount of preload. What they're referring to is the amount of bearing crush from end play. Again, end play, which you guys already know, is going to be the up and down movement, and preload is going to be the opposite of that. It's going to be the amount of crush you apply to the assembly. So that's what we're going to talk about in the next video. I'm going to break these up into a couple segments to kind of make it work a little better for you. But again, tapered roller bearing setup. This is going to be a match set. If you are replacing one of these and there's another one on the other side of the assembly, both of those need to be replaced. When you go back together and you put this together, typically your tapered roller bearings are set to a preload. Okay, preload. Preload, again, is the mathematical equivalent of the crush, the amount of crush from end play. So if you've got an end play, you have no preload. Once you establish preload and you crush this, you're actually going to notice it's going to be difficult to rotate this. And if it's difficult to rotate, if you're having trouble rotating this back and forth, it's because you've achieved a preload. Once you've achieved the preload, you're going to measure that preload with a device called a torqueometer. A torqueometer is nothing more than a dial torque wrench that measures the resistance to rotation. It measures how many inch-pounds typically it's required to make that bearing rotate in the assembly. So to get that thing to continue to rotate, we're going to rotate around with what they call a dial torqueometer. Some guys will use a beam style torqueometer, and that'll work. But I typically recommend getting a really good dial torqueometer and measuring that preload. And again, we're going to be covering this in later videos and later activities. So hopefully you get it. And we'll see ya.